A pleasant and a rainy morning, everyone. This is Langgamas Apple Chain, one of the Group 6 presenter, and our topic is all about the mathematical invention. So I want you guys to take time to watch, listen, and understand our video presentations as we discussed our said topic. So again, mathematical invention by Group 6. So, mathematical invention is the creation of new mathematical concepts, methods, and theories. It's a process driven by curiosity, intuition, and rigorous logic, resulting in the expansion of mathematical knowledge. Unlike scientific invention, which focuses on understanding the physical world, mathematical invention deals with abstract structures and relationships. So, it tells here that it's the process driven by curiosity, intuitions, and rigorous logic. When we say rigorous logic, guys, it means like kumbaga demanding heights or demanding high standards. Or in mathematics, it's like precise and exacting calculations. Dili siya basta-basta. So unlike scientific invention daw that according to science, to see is to believe. But in mathematical world, it deals with abstract structures and relationships. Abstract means non-physical. So, when you say mathematical inventions, dili siya like science, but even abstract siya, we can prove, we can solve problems, even dili nato makita, but through calculations. So, we have here some mathematical inventions. So, we have here mathematical notation, axiom or axioms, and mathematical modeling. So, mathematical notation is a system of symbols and conventions used to represent mathematical concepts, objects, and relationships in a concise and unambiguous way. It enables effective communications and manipulation of mathematical ideas. So, as you can see, there are types of mathematical notations. Symbolic notations uses symbols. For example, if it is addition, subtraction, multiplications, or divisions, naa siya symbol para ma-identify pagdali unsa nga laong pa unsay tawag ani kanang unsa siya na operator ang gigamit. So, symbolic notation. And also, we have here algebraic notations, which is represent variables and expressions. Na siya example given. Also, the functional notations and matrix notations. Also, the logical notations. And also, mathematical notation plays a crucial role in mathematics, science, and engineering due to its because sa iya characteristic which is clarity and precisions. Kasi nga, notations kumbaga eliminates ambiguity, ensuring accurate interpretation. So, dali ra siya masabtan or easy to get its point. And also, notation facilitates theorem proof also. So, an axiom, postulate, or assumption is a statement that is taken to be true, to serve as premise or starting point for further reasoning and arguments. The word axioms, from an ancient Greek word, meaning that which is thought worthy or fit, or that which commends itself as evident. So, an axioms came from the Greek word means worthy or worthy. An axiom is a statement, only a statement that is taken to be true, serves as a premise or starting point for further reasoning or arguments. So, simple word, it means axioms is a statement that everyone believes it's true. So, here's an example of axioms. So, here's an example of axioms. This is an axioms because, as you can see, you do not need a proof to state if it's true, because as it is evident naman in itself na for good ang answer. And also, let's remember always that axioms is a statement that everyone believes is true. So, statement only siya. So, I know that it's easy to get the point or understand what axioms mean in mathematical invention. So number 3, the model of the world or the mathematical modeling. So as you can see, mathematical modeling or turning real life stuff into math equations is a mathematical concept that has various applications. It helps design safe cars, predict the weather, and even understand how diseases spread. So example of mathematical modeling, guys, are pie charts, tables, line graphs, and diagrams, which is applications yan na dali na to masabtan ang point. And also, one of the most significant applications of mathematical modeling is in epidemiology, as you can familiar with that. It is the study of how the diseases spread, like sa coronavirus. One of the application yun na ginagamit nila is the epidemiology na through epidemiology makita nila na how kapaspas mo spread ang diseases during COVID-19. And also, it's helpful kaayo na through mathematical modeling, dali na to masabtan ba, kumbaga ma-identify without hassle na through mathematical modeling. It is helpful pod sa ato life now para mapadali and dili siya time consuming. And also helpful siya na gina-invent kani adto that until now naga-exist gihapon. So mao tong tulo or 3 that includes mathematical invention. So now there are most impactful mathematical inventions that have changed the world, which is kani siya nagpabilin nga one of inventions na kanunay helpful ang ginagamit even now na lang pa sikat siya karon or most or common na ginagamit until now, which is we are going to discuss. So we have here the first we have zero that is invented long time ago but until now ginagamit gihapon siya nato. So, according to our presentation, Brahmagupta, the 7th century Indian mathematicians. The concept of zero was a groundbreaking invention in mathematics. It enabled the development of place value systems, which are essentials for modern arithmetic. So, the story behind it is that Aryabhata, a great astronomer of the classic age of India, was one who invented the digit zero, for which he became immortal but later on is given to Brahmagupta, who lived around a century later, 22, another ancient siya na Indian mathematicians. And also, zero is a number na we already know naman that zero is a number representing an empty quantity. When we say empty quantity, kumbaga wala siya value. Adding zero to any number leaves that number unchanged. For example, 1 million plus zero. It's still the same 1 million. Walay madugang tungod kay walay value ang zero. Empty quantity. Walay value. But it also helpful ang zero tungod kay, for example, ang 2 itapad mo sa zero, may mo siya whole number. Wala siya value at the same time, grabe siya ka kumbaga, use siya, gamit siya, and important siya. And so next one we have algebra. The inventor or the one who invented algebra is Muhammad Khwarizmi, the 9th century mathematician, a Persian mathematician, and he is also known as the father of algebra. Algebra is the branch of mathematics that deals with symbols and the rules for manipulating them. It's a powerful tool for solving equations and understanding relationships between variables. So, the invention of algebra daw in ancient India allowed mathematicians to perform complex calculations and solve problems that are previously impossible. So, when we say complex, murag lisod-lisod na gyud. So the inventor of algebra is Muhammad Khwarizmi, the 9th century Persian mathematician, also known as the father of algebra. So here's an example of algebraic equations. So you can see that algebraic equation 3 is the coefficient, the x is the variable, and the additional like plus sign is the operator para ma-identify if it is multiplication, division. So na ang operator to identify its symbol. So we have here the operator, which is the additional symbol. The 4 and 28 is the constant. So that's the basic algebraic equations. And also, algebra is a branch of mathematics, laong pagani, that uses mathematical statements to describe relationships between things that are vary. So if feel nato na it's impossible na may answer yaon, but naagyod if we know the algebra, which is impossible turn to possible, laong pa, which is solve complex situations, which is seems impossible. So that's all about my part, and the next reporter will be Monterosa Vanessa.
Good day everyone, I am Vanessa E. Monterosa from Group 6, and our topic is about mathematical invention. Mathematical invention refers to the creative process of developing new tools, concepts, and application within the framework of existing mathematical principles. There are few examples of many groundbreaking mathematical inventions that have shaped our world. These inventions allow us to solve complex problems, understand the universe, and create technologies that have transformed our lives. Here are some most impactful mathematical inventions that have changed the world. 1 is zero, 2 is algebra, trigonometry, decimal system, quadratic formula, Fibonacci sequence, and binary code. Another mathematical invention is the trigonometry by Hipparchus of Nicaea, the father of trigonometry. Trigonometry is a branch of mathematics that deals with the relationships between angles and sides of a triangles. It is used in a wide range of fields, including surveying, navigations, and engineering. The development of trigonometry in ancient India provided a framework for understanding angles and their relationships to lengths, revolutionizing our ability to measure and understand the physical world. There are 6 functions of an angle commonly used in trigonometry: the sine, cosine, tangent, cotangent, secant, and cosecant, and are useful for finding heights and distances and have practical applications in many fields. The architecture uses trigonometry for designing roofs, including height and inclination. Crime investigation. The forensic scientist and crime detective use trigonometry to analyze crime scenes. Example, used to study blood spatter. Second, analyze gunshot holes and estimate the trajectory of a projectile. And the surveying. Land surveyors use trigonometry to measure distances, heights, and angles between points of the land. They use these measurements to create topographic maps, determine property, boundaries, and design irrigation systems. Another invention is the decimal system. Al-Khwarizmi, the Persian mathematician, also the father of algebra. The decimal system is a number that uses 10 digits from 0 to 9 and a place value system. It was first recorded in Indian mathematics and is the foundation of modern mathematics and science. The decimal system allows for efficient representation and manipulation of numbers, making it a cornerstone of our modern world. In this system, in algebra, decimals are one of the types of numbers, which has a whole numbers and a fractional part separated by decimal point. The dot present between the whole number and fraction part is called the decimal number. Decimals also are used in many aspects of our daily life, example in money. Also used in financial transactions such as calculating change, tips, and budgeting. And in science and medicine are used in scientific measurements and medical dosages. And also in sports, used in sports for scoring or measuring times such as swimming or running races. Next is the quadratic formula. Quadratic formula is a mathematical formula that provides the solution to quadratic equations. It was discovered by Indian mathematician Brahmagupta in the 7th century CE. The quadratic formula has had a profound impact on mathematics, allowing for the solution of a wide range of problems in various fields. Quadratic formula is a formula that finds the roots of a quadratic equation. In a quadratic equation of the form fx equals ex squared plus bx plus c, where a, b, and c are real numbers, the quadratic formula finds the roots or solutions of this equation. Quadratic equations are used in many aspects in real-life situations, such as calculating the areas of an enclosed space, the speed of an object, the profit and loss of a product, or curving a piece of equipment for designing. According to Thomson, goes on to write that most engineers frequently use the quadratic equations. He says that quadratics are used necessarily in the design of equipment that is curved like auto bodies. Auto engineers use these equations to help create the brakes best possible for people to use. And also, physicists and astronomers, of course, the mathematician used the quadratic formula. Another mathematical invention is the Fibonacci sequence. Leonardo Pisano Fibonacci, the Italian mathematician in 19th century. The Fibonacci sequence is a series of numbers in which number is the sum of the two preceding ones. It was first described in India and has since found applications in various fields including computer science, biology, and art. The Fibonacci sequence demonstrates the power of mathematical patterns and their ability to describe natural phenomena. Many writers begin the sequence with 0 and 1, although some authors start from 1 and 1, but most of the time the sequence begins with 0 and 1. As you can see, it starts with 0. 0 plus 1 is 1, and 1 plus 1 equals 2, 1 plus 2 equals 3, and so on. All you have to do is to add the two numbers to get the next number of Fibonacci. Fibonacci sequence is not only in numbers. There is also a Fibonacci sequence in nature, such as spiral forms. Example, sunflowers. The seeds and leaves of a sunflower are organized in a spiral pattern. The pine cones, similarly to sunflowers, pine cones also have a spiral that follow the Fibonacci numbers. Each scale in a pine cone is arranged in a spiral pattern. When you count the spirals going in one direction, you might find 5 spirals going in one direction and 8 in the other, or 8 spirals in one direction and 13 in the other. If you divide this number, you will get values close to the golden ratio. Next invention is the binary code. Binary code by Gottfried Leibniz, a German polymath, published in 1703a. Binary code is a system of representing data using only two digits, 0 and 1. It is the foundation of modern computers and digital technology. While the binary code was later discovered in the West, evidence suggests that it was used in India before the 2nd century. The binary code assigns a pattern of binary digits, also known as bytes, to each character. As you can see, the numbers above are the 8-byte binary digits, and below of that is the binary code of 93. Now, to get the binary code of 93, we have to find the possible number that could result to 93. Let's start in 128. 128 is bigger than 93, so it could be 0. Next is 64. 64 is possible to 93, so it could be 1. Next is 32. 32 is not possible because if we add 32 to 64, the result will be 96. So 32 is not possible, it could be 0. And then 16. 16 is possible because if we add 16 to 64, the result is 70. Therefore, this is 1. Now, let's continue finding the numbers or binary digits to complete 93. Next is 8. 8 is also possible, so it is 1. And then 4. 4 also is possible, so it is also 1. The remaining numbers are 2 and 1, and we only want to complete the 93. Therefore, 2 here is 0 and 1 is 1. We've completed already the 93. Therefore, the binary code of 93 is 01011101. Always remember that 1 represents the possible number that are asking to get the binary code, and the numbers that are not possible, automatic 0. In this example, we are asking the binary code of 51. As I mentioned a while ago, we have to find the possible number that could result to 51. Now, let's start in 32. 32 is possible in 51, right? So, it is 1. And then 16 also is possible. It is also 1. Now, the 8 is not because if we add 8 to 32 and 16, the result will be 56. So, it is 0. And also 4 is not possible. This is also 0. Now, the remaining 2 and 1 are possible to get the 51. Therefore, this is 1 and 1. Now, the binary code of 51 is 110011. That's all for my part. Thank you.
So good day everyone. So my name is Jamal Suarez. So my topic is importance of mathematical invention. So ang importance sa mathematical invention, so importante gid ang invention sa matematika kay iniya mo ang magamit sa ato gigamit para masabtan ug makontrol ang atong world. So makatabang ini sa ato sa pagsulbad sa mga problema o pagtugot sa mga butang ay mga structures o paghimo o sa mga desisyon na may hibawan sa tanan aspect sa kinabuhi. So first, foundation for science and technology. So, ang matematika mao ang pundasyon sa science of technology. So, ini ang naghatag sa language, sa tools o sa framework para pagsabot sa natural sa kalibutan o para paglambo sa mga bagong solusyon sa komplikado na mga problema. So, ikan sa mga balaod sa atong mga computer o sa math o amo ang fundamental sa matag scientifico So napagka-discovery sa technology or technology nga pag maswag. So panduha, problem solving and decision making. So mathematics equips us with the tools to analyze situation. So identify the patterns and develop logical solution. So ang mathematics naghatag sa ato ng aron ma-analyze o ang mga sitwasyon o situation. So mahibaw-an ang mga patterns o makahimo og logical na mga solusyon. So pantulo, innovation and creativity. So mathematical concepts like algorithms and logical reasoning are the fundamental or foundation of innovation. So ang mga concept ng mathematics sama sa mga algorithm o logical nga pagkatawag ng mao ang pundasyon sa inovasyon. Kasabot niini nga ang prinsipyo sa pagtugot sa ato nga paglambo sa bag-ong teknolohiya, pagdisenyo og epektibong nga sistema o pag-atubang sa mga problem na gikan sa bag-ong nga mga pag-upat. So understanding the universe. Understanding the universe. So ang mathematics mao ang gikan sa mga balaod sa piska o sa mga mga cosmos. So hangtod sa mga komplikado na mga simbanan, mga makita sa mga kinaiyahan taon. Og ang mathematics naghatag og usa ka alang sa pagsabot sa mga sungaran sa paglihok sa universe. Lima, so cultural and historical significance. So mathematics has shaped human civilization throughout history. So from ancient civilizations, advancements in geometry and astronomy, to modern technological marvels, math has been a driving force behind cultural and historical progress. So, ang mathematics nag-umoy sa sibilasyon sa tao, sa tibok o sa kasaysayan. So gikan sa mga karaan ng mga sibilasyon ba ang mga pag-uswag sa geometry o astronomiya hangtod sa modernong mga technological na kinahanglan katingalahan. So ang matematika or mathematics usa siya sa nagmahimo og pwersa sa likod sa cultural o sa mga kasaysayan para sa pag-uswag. Personal growth and development. So engaging with mathematics fosters critical thinking, logical reasoning, and problem-solving skills. So, ang pagkipagbahin sa mga mathematics pagpalambo sa critical nga pangunahuna. So, critical na pagtarungan o mga kahanap sa pagsulbad sa problema. So, mautotanan mautotanan sa importance of mathematical inventions, so foundation for science and technology, innovation and creativity, problem solving and decision making, understanding the universe, cultural and historical significance of personal growth and development. So that's all. Thank you, guys. So good day, everyone. So my name is Jamal Suarez. So my topic is importance of mathematical invention. So ang importance sa mathematical invention, so importante gid ang invention sa matematika kay ini amo ang magamit sa ato gigamit para masabtan ug makontrol ang ato world. So makatabang ini sa ato sa pagsulbad sa mga problema o pagtugot sa mga butang o mga structures o paghimo o sa mga desisyon na may hibawanan sa gitanan aspect sa kinabuhi. So so first, foundation for science and technology. So, ang matematika mao ang pundasyon sa science of technology. So, ini ang naghatag sa language, sa tools o sa framework para pagsabot sa natural sa kalibutan o para paglambo sa mga bagong solusyon sa komplikado na mga problema. So, ikan sa mga balaod sa ato mga computer o sa math o amo ang fundamental sa matag scientifico. So, pagka-discovery sa technology or technological nga pag-uswag. So, panduha, problem solving and decision making. So, mathematics equips us with the tools to analyze situation. So, identify the patterns and develop technological solution. So ang mathematics naghatag sa ato na aron ma-analyze o ang mga sitwasyon o situation. So mahibaw-an ang mga patterns o baka mo og logical na mga solusyon. So pantulo, innovation and creativity. So, mathematical concepts like algorithms and logical reasoning are the fundamental or foundation of innovation. So, ang mga concept ko ng mathematics, so sama sa mga algorithm o logical nga pagkatarong ng mao ang pundasyon sa inovasyon. So, kasabot niini nga ang prinsipyo sa pagtugod sa ato na paglambo sa bagong teknolohiya, pagdisenyo og epektibong nga sistema o pag-atubang sa mga problem na gikan sa bagong nga mga pangapat. So, understanding the universe. Understanding the universe. So, ang mathematics, so mao ang gikan sa mga balaod sa piska o sa mga mga cosmos. So, hangtod sa mga komplikado na mga simbanan, mga makita sa mga kinaiyahan taong og ang mathematics so naghatag og usa ka alang sa pagsabot sa mga sungaran sa paglihok sa universe. Lima, so cultural and historical significance. So mathematics has shaped human civilization throughout history. So from ancient civilizations or advancements in geometry and astronomy to modern technological marvels, math has been a driving force behind cultural and historical progress. So, ang mathematics, nag-umol sa sibilasyon sa tao, sa tibuok o sa kasaysayan. So, gikan sa mga karaan ng mga sibilasyon ba, ang mga pag-uswag sa geometry o astronomiya hangtod sa modernong mga technological na kinahanglan, katingalahan. So, ang matematika or mathematics, usa siya sa nagmahimo og pwersa sa likod sa kultural o sa mga kasaysayan para sa pag-uswag. Personal growth and development. So, engaging with mathematics fosters critical thinking, logical reasoning, and problem-solving skills. So, ang pagkipagbahin sa mga mathematics, so, nagpalambo sa critical nga paghunahuna. So, logical na ngatarungan o mga kahanap sa pagsulbad sa problema. So, mauto tanan mauto Maututanan sa importance of mathematical inventions, so foundation for science and technology, innovation and creativity, problem solving and decision making, understanding the universe, cultural and historical significance of personal growth and development. So that's all. Thank you, guys.